Section 7-1 is about ratios and proportions. And to start off, I want to give you an example of this man, Pierre Scerri, built a Ferrari that is exactly 1/3 the size of a real Ferrari. So he built the engines and all the gas valves and the tires and the spokes and everything that's on a real Ferrari exactly 1/3 the size. It's actually a really interesting YouTube video if you want to watch it. Okay, but that 1/3 is the ratio between his model Ferrari and an actual Ferrari. So a ratio is a comparison of two quantities by division. So it's a way of comparing two quantities. Okay. Now ratios can be written in three ways. It can be written as a fraction, a over b. It can be written as with a colon, a to b, or in words, a to b. Okay, so in our Ferrari example, the car was 1/3 the size of the actual Ferrari. The ratio is 1:3, or in words, 1:3. Okay, now, as far as a question, what is the ratio of trapezoids to squares on this page? And to use all three ways of writing a ratio. Okay, now be very careful about the wording. It says trapezoids to squares. So the number on the left, or the number on the top of our fraction, will represent the number of trapezoids, where the number on the right, or the number in the denominator of our fraction, will be the number of squares. So let's count them. There's 1, 2, 3, 4 trapezoids, and 1, 2, 3, 4, 5, 6 squares. Okay, so the ratio as a fraction is 4/6. Okay, using a colon, it's 4:6, and using words, it's 4:6. Okay, again, notice that I'm doing it in the same order that I was asked. Okay, now this ratio can be reduced. Okay, so the ratio is a way of comparing two quantities. Okay, and although it's true that there are exactly 4 trapezoids and exactly 6 squares, the ratio of trapezoids to squares is the same as 2:3. Okay, so for every 2 trapezoids, there are 3 squares. Okay, and I could take this ratio and make it larger and say, to keep the ratio the same, I could have 8 trapezoids and 12 squares, or I have 40 trapezoids and 60 squares, and the ratio would still be the same. Okay, so we can reduce the ratio by saying 2/3, or we can look at larger quantities with the same ratio. Okay, now I'll write it simplified in colon 2:3, or 2:3. It's a good habit to get into reducing ratios, just like it was a good habit to get into reducing fractions, just because they're easier to work with if they're smaller numbers. Okay, so the following pictures show the ratio of girls to boys in a geometry class. Okay, so there are 5 girls and there are 6 boys. Okay, if the ratio is the same for all students taking geometry, and we know that there are 70 girls taking geometry, how many boys are taking geometry? Okay, so the ratio for all the students taking geometry is the same as for this class. And we know that there are 70 girls taking geometry. How many boys are taking geometry? Okay, now we're going to use the ratio of boys to girls. Now we'll use it in a fraction form. That'll be easier for us. And I'll use the fraction of 5/6. Okay, now notice that the top number represents the number of girls, and the bottom number represents the number of boys. Okay, and we're going to set up a proportion, which is where you have 2 ratios or 2 fractions that are equal to each other. Okay, but it's very important that you keep the fractions to be the exact same. Okay, so in this case, the number representing girls is on top, and so I'll put 70 in the numerator of this fraction, and I want to know the number of boys, which is x. I'll put that in the denominator over here. Okay, and then I will solve this proportion. Now, you probably are familiar with solving proportions, and we'll use cross multiplication. So if I multiply 6 times 70, I will get 420. If If I multiply 5 times x, then I get 5x, okay? Now notice that there's an equal sign in this equation and an equal sign in this equation, okay? Sometimes students miss that equal sign. Okay, move this. So to solve this, I will divide both sides by 5, okay? And x is equal to 84, okay? So there are 84 boys taking geometry, okay? I hope that makes sense. Now let's move down to the next problem. If the ratio is the same for the entire school, and we know that there are 550 students in the school, how many girls are in the school? Okay, now again,